Okay, so another example to the constant acceleration formulae. So we've got particle p moving on the x-axis with constant deceleration 2.5 meters per second squared. When t equals 0, p passes through the origin moving with velocity 15 meters per second. We're going to find the time between when p first passes through O and when it returns to O, and the total distance travelled in this time. Okay, so part A, if we start thinking about things that we know, we're told the deceleration is 2.5, so therefore the acceleration is minus 2.5 meters per second squared. We've got a velocity, an initial velocity of 15 meters per second, and we're told we're returning to the origin, so that means that actually the displacement is 0, not the distance but the displacement. We want to find the time, so t is a question mark. The equation connecting those is s equals ut add a half at squared. So we're going to substitute everything into that. So 0 equals 15t, half times minus 2.5 is minus 1.25 t squared. So then we can solve that. So we could factorise, take out a factor of t, and then we can just solve that from there, and we would get either t equals 0 or t equals 12 seconds. So obviously 0 is when we first go through O, so return to O after 12 seconds. Okay, part B, we want to get total distance travelled in this time. So that seems a bit strange because we've returned to where we started. So as I said before, that's the displacement. The displacement is 0, but not the distance. So what we want to think about is going on here. We've got this particle. It goes through O and heads out somewhere over here. There comes a point where it's stopped and it's then coming back to O. So this is where we start from. And that's when we've got a speed of 15 meters per second. Here the speed is 0 meters per second, so that's when it's stopped and it's turning around. So that's how we're going to answer this problem. We're going to work out all the distances from here to here, and then we just need to double it to get the total distance travelled. Okay, so we've got an initial velocity of 15 meters per second. We've got final velocity of 0 meters per second. The acceleration comes from before as minus 2.5 meters per second squared. S is what we're trying to find. So the equation that connects those is v squared equals u squared plus 2as. I can substitute those values in now. So I've got 0 is equal to 15 squared minus 1.25s. So that's the same as saying 1.25s is equal to 225. And then we solve from there to find what s is. And that's equal to 180 meters. So the total distance travelled is 2 lots of that. So 360 meters.